In this video, we are going to see about a Python project which is entitled as Signature Fraud Detection Using Deep Learning, which is an enhancement of IEEE base paper title Offline Handwritten Signature Verification Using Image Processing Techniques, which is an IEEE 2023 conference paper. Before seeing the execution of the project, let me brief about this project. So even in this digital world, we use the handwritten signatures for various purposes of for legal transaction, bank checks, or for land documents kinds of things. And also due to this kind of handwritten signature, there is also problem of making the fake signatures same like the original one. So there are various types of techniques available for identifying the signature which is original or fake, and in the base paper the authors have used the image processing techniques. So here they have used image processing technique, and they apply the image processing techniques, and they are going to identify whether the signature is a valid signature or not valid, that is it is a original signature or not. So considering this base paper, so now we are going to make the enhancement by applying the deep learning technique. So now let us see about our proposed system. So here we are going to use the algorithm or model which is Siamese Neural Network. So we are going to use an unique CNN model which is Siamese Neural Network in this proposed signature fraud detection using deep learning, and we have achieved a training accuracy of 98% and the validation accuracy of 99%. So now let us see the proposed system document. So here you can see the base paper title Offline Handwritten Signature Verification Using Image Processing Technique, or you can use our proposed project title, that is Signature Fraud Detection Using Deep Learning. So this is the base paper abstract that is mentioned in the base paper. So now let us see our proposed abstract. So in the proposed abstract you can see the basic introduction of the project of the signature verification using Siamese Neural Network, and here you can see about the data set part. So here the data set contains around 2149 signatures, so images. So it contains all 2149 images which contains both genuine and fraudulent samples. So based on that we will be training the model. So I'll show you the data set part before proceeding the next thing. So in the source code folder, the model folder, we have the signed data which contains the test and train folder. So in the each folder we have various kinds of signatures. So now let us show you one by one. So here you can see 001. So this is a signature of a particular person. So for that identity they have made the numbers as 001. So here you can see this folder contains around 24 samples of the image signature of the person. So here you can see the another folder with the same ID, the forged. So here you can see the forged image signature. So in this way you can see there is around 128 folders of the train folder, and also in the test we have around 42 folders. So here both they contain about the genuine and the fake, that is the original and the forged signature. So this is the sample. So all the images are in the PNG format. So here you can see the sample images like this only. So each folder has the various samples of the signatures. So this is about the data set part. Now coming to the abstract document. So here you can see that we have achieved the accuracy of around 98% of the training accuracy, and the test accuracy around that to 99%. And coming to the existing system, as mentioned, we are considering the base paper as existing system. So in the base paper they have used image processing technique, computer vision image processing technique, so that details have been mentioned in the existing system part. And coming to the disadvantages of the existing system, so we have listed the various disadvantages of the existing system using the image processing technique. And coming to the proposed system part, so as mentioned we'll be using the Siamese Neural Network, and the core proposed system is utilizing this neural network. This is the type of deep learning architecture designed for similarity measurement task. So wherever we wanted to find a similarity of particular or two images, so we can use this Siamese Neural Network. and we are going to use the Python programming language, and as mentioned we'll be using 2149 signature images here. And about the accuracy part, so these are the things that is being mentioned in the proposed system. And coming to the advantages of proposed system, so we have listed about the advantages of a proposed system, especially the accuracy part and various factors. These have been listed in the advantages of the proposed system. And coming to the system architecture, you can find the signature image data set as the input here, and it is being trained up using on pre-processing feature selection is made, and it is being trained up using the Siamese neural networks. And also the predicted result is being predicted as real signature or it is a fake signature, and finally we will be showing a graph in it. And coming to the system requirements, you can see the hardware requirements and the software requirements. So as mentioned, we'll be using Python, and the particular version of Python that we have used is Python 3.10.9, and the web framework we have used is Flask web framework, and for front-end part we have used HTML, CSS and JavaScript. And this is the reference of the project, that is the base paper reference of the project. Before execution, make sure that you have fulfilled the requirement that is mentioned in the requirement file with the exact version of the Python or the libraries installed in your system. So now let us see the execution of the project. So first copy the source code location, go to your command prompt. First go to the drive location where you pasted the code. In my case, I have pasted the code in the F drive, so I'll go to the F drive. Now type cd and give space and paste the location that we have copied and click enter. Now we are into the source code location. Now let us type the command python app.py and click enter. Now kindly wait for a few minutes. So now you can see this URL. Just copy this URL, go to any of your browser. I'm going to Google Chrome. So just paste the URL that we have copied and click enter. And now you can see the home screen or welcome screen of the project with the project title, signature, fraud detection using deep learning. So first click this login menu. So it will be navigated to the login page, and kindly note that this is a static login page because we have not used any database in the project. So just enter the default username and password as admin and then click the login button. So now you can see the login success message and click OK. So now it will be navigated to the preview part. So here you need to upload the images of both original and fake. So whichever you need to compare, you can need to upload, and we will be checking out. So first let me select the choose file. So now let me go to the source code folder where we have the train data in the model folder, and we have some few samples in the test data. I'll show you both the time. So just let me go to the test data type. So now let me go to the first folder, let me select an image, and this is the original image I have selected, and let me go to the choose file. So now let me select the image from this forged file. So now let me click submit, and now you can see the prediction result in the prediction page. Now you can see the preview the images. So I have given two images. You can preview. The left side is the original and the right side is the forge which I have given. So now you can see the images and also the prediction result. The prediction result is the signature is fake, so it is predicted correctly as it is a fake. So now let me check with other case. So just click the preview menu again. It will be navigated to the preview page. So this time I'll just go to the test data folder again. I'll just select the both as original. So let me select the first one, and also let me, and this time I'm not going to select the forged image. So in the same folder I'll select some different image and click submit. So now you can see both the images I have selected, and also you can see the predicted result. The signature is a real signature. So now let me click the preview part. So if I'll just go to choose file. This time I'll go to some other folder. So let me go to this folder. Let me select the same image now for both the cases to show you a sample. Just click the submit. So now you can see the signature is real. So here you can see this is the real signature. This is the test that we wanted to check whether it is a real or not. So it is being compiled and it is shown that the signature is a real one. So now let me go to the preview part. So now let me select the real folder, and also let me go to the for test I'll go to the forged image. I'll select an image for it and click submit. So now you can see both the images which I have selected, and also you can see the printed result is a fake one. So I'll go to the preview one. So this time I'll go to the trained folder. So just go to the source code folder. The model folder we have signed data, in that we have the train folder. So there are in the train we have lots of images. This type I'll go to, let me go to 50 and let me select an image. So this is the image I selected, and let me go to the forge folder and let me select some other image randomly and click submit. So now you can see both the images that I have selected, and now you can see the printed result is a fake image. First it's a fake signature. So now let me go to the preview part again. So now this time I'll just go to some other folder, say example, let me go to this one 40. Let me select an image in the same folder. There are lots of images. I'll just select in the same. I'll just submit. So now you can see both the images, and it has been printed as the signature is a real signature. So in this way you can check with the all other cases whichever is available on various combinations whichever you wanted. So finally I'll show you with the test folder which is available in the signed data what. So let me go to this folder. Let me select an image. Let me go to test. Let me select an image from the forged part and then click submit. So now you can see both the images that I have selected, and also you can see the printed result is a fake signature. So I have shown you with both the cases of real and fake with various images. You can check with other things, and finally I'll come to the chart part. So just click this chart menu. It will be navigated to the chart part. Kindly note that this is a static chart only, because we have not used any database in the project as mentioned earlier. So this chart is being depicted with showing the number of percentage of the real signature and fake signature. So there are two cases, real and fake. So in the dataset part we have 50% with the real signature and 50% with fake signature. So that is being depicted here in the chart part. So that is the reason I said that this is not a dynamic chart. So this is a static chart only, as we have used the plotted manually with the dataset part component. So now let me log out from this part. So this is all about the project signature fraud detection using deep learning using Python, and thank you for watching.